It was the biggest and most highly classified project of World War II. It was more highly classified than the Normandy invasion. It had number one priority in everything.
It wasn't easy. You know it's got to be done, so you grab it and run with it. Get the job done.
It was a job unlike anything the world had ever seen.
It was the business end of an atomic bomb. It was plutonium. It was the first. It was going to change the world.
Well, the first time I ever got into it, I was just astounded because I just could not imagine the effort that it took to do that.
It did a lot of good. It did a lot of damage. I think every American, in fact, every citizen of the world needs to know about Hanford.
Funding for Oregon Experience is provided by the Robert D. and Marcia H. Randall Fund for Lifelong Learning, the James F. and Marion L. Miller Foundation, the Oregon Cultural Trust. Additional support provided by Kei Kitagawa and Andy Johnson Laird, the Clark Foundation, the Roundhouse Foundation, Fran and John von Schlegel, and viewers like you. Thank you.
The war was not going very well after the Japanese bombed Pearl Harbor. The Japanese took a whole bunch of people on what was called the Bataan Death March. It was this terrible situation. Our boys were being killed, and the war in Europe was pretty grim then.
When we entered the war, the Allies, the side that America was on, were losing the war. We were actually losing. And that's hard for people today to believe, because we always think of the United States as being so powerful.
We were frightened. This country might be invaded, we might be taken over like Poland. The war was real then.
In Germany, new scientific discoveries had sparked more fear. In 1939, two scientists had split or fissioned the nucleus of a uranium atom.
It was a very big deal indeed, and every major country knew the implications of that, if indeed a runaway chain reaction could be produced.
Scientists knew that when a uranium atom is bombarded with neutrons, the uranium nucleus can split, releasing energy and more neutrons.
If those neutrons now split other uranium atoms, that could go on and on. Physicists were thinking that it could make explosives of hitherto unheard of amount of energy and violence.
The race to build the ultimate weapon of war had begun. In 1939, President Franklin Roosevelt received a letter signed by Albert Einstein, urging more research into this new science and potentially new kind of weapon. Soon after, Roosevelt began asking America's top scientists for help. And in 1941, a new discovery brought the possibility of a super bomb one step closer. While experimenting with uranium, chemist Glenn Seaborg isolated a new element.
Plutonium is a man-made element that you make by bombarding uranium.
Plutonium was highly fissionable, and like uranium, could possibly be used as fuel for an atomic bomb. But the only way scientists could produce enough plutonium for a weapon would be through a controlled nuclear chain reaction. And that had never been done, until a recently emigrated Italian physicist went to work at the University of Chicago.
On December 2nd, 1942, Dr. Enrico Fermi built what's called Chicago Pile 1, and that is the actual first reactor in the world. Let's remember, it wasn't a building, it was simply a pile of graphite. It was temporary. It didn't have a cooling system. It's very important. It operated at such a low power level, 1/2 of a watt.
I was absolutely flabbergasted. I had never heard of a chain reacting pile. And I think if you look back at some of the reports, you'll find that the secret statement was made to Washington that the Italian navigator has arrived in the New World and found the natives friendly. That was a sign that the nuclear chain reaction had occurred.
Dr. Fermi succeeded in causing the first sustained, controlled nuclear reaction. So it proved it was possible, but it certainly wasn't the same thing as going out and building something production scale.
But with a war raging and pressure mounting, Roosevelt had authorized what became known as the Manhattan Project, a top-secret mission to build a nuclear weapon. It became one of the biggest gambles in American history.
You couldn't have done this in time if you waited to prove everything ahead of time. It would take years. And they just decided, we'll do it, we'll succeed or we'll fail, but we have to go fast.
And Germany, of course, had a head start on us. If they had gotten the nuclear explosive first, they would have won the war. If we got it first, we win the war. This was the basis on which everybody worked and knew that that was what was at stake.
In the fall of 1942, U.S. Army Corps of Engineers General Leslie R. Groves, fresh from building the Pentagon, was chosen to oversee the entire project. To increase the odds of success, Groves chose to simultaneously pursue production of both a uranium and a plutonium-fueled bomb. Scientists would design and develop the weapons at Los Alamos, New Mexico, under the direction of physicist J. Robert Oppenheimer. A massive plant at Oak Ridge, Tennessee would produce weapons-grade uranium. Scientists there would also make small amounts of plutonium for continued research.
At first, we were only getting thousandths of a gram, 1 milligram of plutonium at Oak Ridge, and gradually worked up to gram quantities.
In the meantime, plans moved forward for a third major plant.
You're going to have to build a city, virtually, of industrial buildings in order to produce plutonium. They had to decide everything about how to build things that had never been built before.
At DuPont, mechanical problems are solved by mechanical engineers.
General Groves hired the chemical giant DuPont Corporation as the plant's prime contractor.
DuPont was a stinker for safety because they had to be. They generated gunpowder.
It worked with explosives, TNT, all kinds of chemical weapons, and its plants were safe.
Managing the plutonium project fell to Army Corps of Engineers Colonel Franklin T. Matthias.
Colonel Franklin Matthias was a young man. He was only 34 years old when this project began. He was given an enormous amount of responsibility. He was into every detail to make sure this project went forward.
His first challenge? Find a large remote location. Matthias and his small team explored most of the western United States, including parts of California and Oregon. From day one, Matthias kept meticulous notes.
December 22nd, 1942. Decided Deschutes River required no further checking, as not suitable based on map and aerial reconnaissance. Hanford site far more promising.
The Hanford site in south central Washington met all the necessary requirements. It was isolated, more than 650 square miles of sagebrush-covered desert. There were no main highways or railways within 10 miles. About 90 miles north, the Grand Coulee Dam was generating abundant electricity. And there was the river, the Columbia. Partially wrapped around the site would provide water.
You need millions of gallons of cold water to run the old-fashioned reactors. And when they saw the empty land here, the fact that you could have the river and the desert without a lot of precipitation, they said, this is it.
But the land wasn't completely empty. Native Americans, including the Wanapums, had treaty rights to use it.
They had an encampment at White Bluff. It was just probably a half a mile of our house that they moved to at the time that they were fishing for salmon.
They were allowed to fish on site while the reactors were being built, which was a good year and a half after the Hanford project was sited. Once the reactors began to operate, no, they couldn't come in anymore.
Besides the tribal camps, 3 small towns hugged the Columbia: Richland, Hanford, and White Bluffs.
A little country town where everybody knew everybody, a nice little town with all of the essential things like the service stations, grocery stores, barber shop, hotel.
Many of the families had come for the opportunity to tend and manage acres of orchards.
My parents, they were in love with that place. They were in love with the community. They were active in the Grange and really pleased with the friends and neighbors that they had.
My parents bought their 10-acre place with a very nice house on it and a barn and 5 acres of peach trees already up, irrigation system in place and running. That was $500. A place for them to farm and grow a future.
The Depression was a very difficult time for White Bluff as well as the rest of the country. And 1943 was really the time of recovery. The crops looked good, orchards were well cared for and productive.
But that year, the bumper crops would go unharvested.
The spring of 1943, my parents got a letter telling them that they were going to have to leave. They had 30 days.
It happened very quickly. There was a meeting at the Grange Hall and the contractor, DuPont, and they met with us and said, you people are going to be gone in 3 weeks. This is a government project. It has to do with the war project, and this is being taken over by the federal government, and goodbye.
I was in England at the time because I had been drafted. What do you say if it's a war that you felt had to be fought and won?
Nobody liked it. I don't think it would have been any different for anybody, you or me or anyone else, when somebody comes in and says they're going to take your property, whether you like it or not. Just a big disappointment.
People were angry. They were upset that their whole lives were being turned upside down. And there was no cash offers. We didn't get paid for years after.
Just downriver, the village of Hanford had been evacuated too, and was changing into a sprawling construction camp, a boom town filled with rudimentary huts and barracks. Life here is a little on the rugged side, read one recruiting brochure.
They had this incredible need for labor. Carpenters were the prime ones they needed out of the gate.
When they began this project in March of 1943, by September of 1943, they had 50,000 workers here. So they were hiring 10,000 people a month. And they're doing it on index cards with pencils. Of course, no barcodes, no computers, no, easy ways to do anything.
People of all creeds and color arrived from across the U.S.
There was as many as up to 5,000 or 6,000 African Americans that actually came in and went during the construction phase. And my uncle, Willie Daniels, he was one of the pioneers from our community from Northeast Texas. So he had migrated out here to work on the Manhattan Project. He would inform people in the community that the work was good, and they pooled their monies and came to Washington.
Women came too and took jobs as clerks, stenographers, and a variety of other jobs. It was by and large a different kind of workforce because most of the younger men were fighting the war.
And so they had to take mostly men over the age of 38. So what they got was the experienced journeymen, best in craft workers. And there were no apprentices here.
The town of Richland survived, but the U.S. government now owned and operated everything.
Richland was a closed community. It's owned as a strictly government town. You couldn't live in Richland without working at the plant.
Project homes and prefabs sprang up for families and more permanent operating and engineering staff.
All I know was that a plant was being built by the government to support the war effort.
Monty Stratton was working under a draft deferment in Ohio when he was hired in 1943.
I thought it'd be a nice chance to see what the Wild West was like. Arrived in Pasco early, wee hours of the morning. I was assigned to what was called the instrument department. And the main reason for that was my background being an electrical engineer. Also, I had electronics experience being an amateur radio operator. Very little information given out as to what the nature of the work was.
There was something big happening at Hanford, but few people knew exactly what. Local, county, and state government had no jurisdiction over the project. No one could get on or off site without clearance.
There was no welcome mat out around here. Armed guards turned visitors back on highways and side roads miles from the center of the exclusion area, and the product being made was shrouded in the deepest secrecy.
The new U.S. Office of Censorship was also asking newspapers and broadcasters for silence on a variety of topics.
March 8th, 1943. The spokesman review getting obstreperous and insisting they print a story. Trying to restrict publicity on this project is like keeping water in a sieve. Franklin Matthias.
But for the most part, the media cooperated. And in the spring of 1943, Hanford Engineering Works, the largest construction project in the world at the time, went to work.
Hanford was kind of the Paul Bunyan. If you think about a persona, this is going to be the burly, roll up your sleeves, get the work done kind of place. And here it was in a corner of the country, very remote, and yet so important that materials would be rushed to it if needed.
Workers began building hundreds of miles of connecting rail lines, roadways, and power lines. Mess halls were another early priority. 8 of them, each the size of a football field, open to feed hungry crews, consuming 8,000 pounds of coffee a day, 120 tons of potatoes. In fact, plenty of just about everything.
If you finished your meal, you held up your plate, and someone would bring another platter. And that didn't happen anywhere else in America, because in the American home at the time, there was rationing. and you could only have meat maybe twice a week. Here at Hanford, you could have as much as you wanted every day. And they paid them and fed them well to keep them here because it was so essential. There was huge turnover. And even though those conditions were good, the isolation, other factors caused many people to leave.
The weather, wind, and sand drove many elsewhere. Engineer Dick Donnell captured life here with cartoon character Dupus Boomer.
Because of all of the construction going on, there was very little vegetation around to hold the sand. Sand was the worst.
You had just one big sandbox out there. And so when the wind blew, it was terrible. My sister-in-law said, you know, just the sand was just so thick on your floor, you could hardly walk on it.
I can remember that being very distressing to my mother, you know, was that every time the wind blew, she had to go around and dust everything and sweep up these piles of sand and stuff that would leak through from no not where.
In those days, they were called termination winds because so many people just couldn't stand that type of living and pick up and go back home to other part of the country.
To further entice workers to stay, Colonel Mathias ordered a giant recreation hall built and attracted big-name bands and singers. There were dances, movies, and entertainment of every kind around the clock.
They did everything to keep us here.
But for many, the strangest part of the job continued to be the secrecy that surrounded it. Less than 0.1% of the workers at Hanford knew what their factory was making.
You never called it plutonium, it was called product. And you never mentioned the word uranium. Uranium was always called metal.
Construction crews were often guided solely by rough sketches and drawings.
They even did their own fabrication of equipment, like machine shops, and they did it all right on the site because they didn't want people to know what was going on.
First of all, you couldn't just put out a specification and say, I need a widget that goes, you know, sideways into the tube of a nuclear reactor, because no one knew how to build that, and also you'd give away the secret.
Mathias was really good at compartmentalizing, so you as a worker would know just enough to complete your portion of it. They were instructed by their foreman and also the construction engineers on what they were to do for that particular day. They also were not at just the reactor. They would be moved around the site so that you could never really piece together everything that they were doing and how the reactor was actually going to operate.
They did have FBI agents mixed in with the workforce, and they did have people that were informing, and you couldn't talk with your coworker. You couldn't say, what'd you work on today? Why does that pipe go from, you know, point A to point B? Because if you asked your supervisor, he would say, don't ask or you won't have a job tomorrow.
If you're going to write a letter to someone, be careful as to what you say. Don't give any details about the nature of your work, and be very careful as to what you have to say on the telephone. In a lot of cases, if it appeared that you were not abiding by the rules and regulations, you'd most likely lose your job and be ushered out of town.
You would see them one day and the next day they were gone.
I arrived at Hanford in October of '44 and was there through January or February of '46. There was always secrecy, not only at Hanford but at Oak Ridge. But everybody was told that what they're working on was so important to the national defense. I remember one bus driver felt so proud of the fact that he was busing people out to the plants, even though he didn't know what was out in the industrial plants at Hanford. But he said, without us, these people wouldn't be able to do the work.
But exactly what they were doing continued to baffle not only the workers, but the residents of nearby towns, too.
What they were thinking was, gee whiz, all these supplies going into the plant, hundreds of tons of materials and food and everything that was required to keep a community of many thousands of people working and fed, but nothing was coming out.
But on the inside, massive structures were going up at an ever faster pace.
December 6th, 1943. General Groves arrived this morning, insisted that the completion of the building could be advanced 2 or 3 months, to which I agreed. Franklin Matthias.
3 identical reactors, B, D, and F, were taking shape in what was called the 100 area along the river.
And you separate them by about 6 miles in between each one. That's in case one has a catastrophic accident.
Inside each, a staggering sight was emerging as well, the face of a nuclear reactor.
It's 5 stories high. It's the height of a 5-story building. It's as wide as a huge movie screen, and it's got these pipes in it that look like a waffle iron.
It was cutting-edge technology of the time.
You take the interior structure, which is called the core, and that is kind of a Lincoln Logs type assortment of pieces of graphite, and you're going to put uranium in tubes that go through the graphite.
They were aluminum clad, and they contained naturally occurring uranium. So those were loaded into the reactor, and when fully loaded, you had anywhere from 200 to 300 tons of uranium in this reactor.
How close does each piece of uranium have to be to the other pieces of uranium? And how much water and how thick can the pipes be before they interfere with the nuclear reaction? And all of these calculations had to be done and then done precisely, carried through by the builder's hands. And it was all based on Dr. Fermi's theories and I'll say guesses, very, very good guesses, but his calculations and his theories. So no one knew exactly how to do this.
Fermi's calculations had called for 1,500 process tubes that would hold the uranium fuel. 9 horizontal control rods could be moved in and out of the reactor core.
When you're loading the reactor, they're inside the reactor and they're absorbing neutrons. So even though you're inserting those 200 to 300 tons, you're absorbing the neutrons, you're not going to have sustained nuclear reaction. It's not until you remove them. That's when the magic occurs.
In addition to that, suspended above the reactor are safety control rods that will drop into the reactor to shut the reactor down in case it runs out of control.
Here's a picture of the one of the reactor plants. We have the river in the background, and the water is pumped out of the river up to the filter plant.
Each of the reactors operated independently with its own pump house. Water was routed around each of the process tubes inside before being discharged out of the reactor and eventually back into the river.
You had to be able to measure the amount of water and the temperature. They were 2 important features of the water that was being pumped through the reactors. To maintain those instruments in good shape it was very important.
With the amount of intense temperature that was inside the core itself, you had to move as much water as you could in the shortest amount of period to dissipate that. And in fact, it took 1 second for the water to go from the front of the reactor to the back of the reactor. Normal temperature was about 54 degrees when it went into the front of the reactor. In that 1 second, it went up to 195 degrees.
You had to pump in the amount of water it would take to supply a major city, such as Seattle. You had to pump that through every day. Water delivery was a huge part of the Hanford project.
The control room was staffed around the clock to monitor the more than 5,000 instruments and gauges and precisely regulate the rate of the nuclear reaction.
This is where your senior operator would sit to operate the vertical safety rods and the horizontal control rods. This was one of the most stressful jobs in the reactor. In fact, his shift would last only 1 to 2 hours.
On September 13, 1944, Enrico Fermi loaded the first fuel slug into B reactor. And on September 26th, less than a year after its construction had begun, the first full-scale nuclear reactor in the world went critical, or into a controlled, self-sustaining nuclear chain reaction. But there was a problem.
And the reaction started to cool down by itself. And then eventually there wasn't enough fission going on to sustain it. And they thought, we have failed. We have done all this and we have failed. And it was daunting. They figured out that there was an isotope being produced that was damaging the fission reaction and slowing it. And they realized that they were going to have to overpower that.
Enrico Fermi says 1,500 tubes. So 1,500 tubes is what it was going to be.
And one of the engineers went to Groves and said, well, what's your contingency? What if that's not enough?
We have a situation where General Groves found himself in the middle between a community of scientists who were brilliant and a community of engineers who were very practical. And General Groves had to mediate. And finally, he was about to say, we don't need any more tubes because the scientists are so brilliant. They've told me they don't need it. But apparently an engineer said to him, what if this fails? Who's going to take the blame? And General Groves turned around, according to the story, and said, how many more tubes do you want?
And they said 504. If they would not have put in those additional 504, bringing the total up to 2,004 process tubes, this reactor would not have functioned.
Instead, B reactor fired back up, a giant atomic furnace that cooked and consumed a new kind of fuel.
When you put uranium fuel into these reactors and you want to make weapons-grade plutonium, you would leave it in about 6 weeks. Every 6 weeks, they're loading and reloading. That's a huge manual effort.
For the first year and a half, Hanford had been just a construction site, with rules and safety regulations common to any large industrial plant. In 1944, everything changed.
When that uranium forms plutonium, it also forms a lot of fission products. The fission products are very, very radioactive, very dangerous.
When radiation began to be introduced on the site and the reactor began to operate, they called it danger. They had rules. They had distances, places you could be, places you couldn't, special equipment you had to wear. But they didn't tell you why. They just said it's dangerous and believe us. But they didn't say it's radioactive.
Strict security rules dictated that workers be told about hazards on a need-to-know basis only.
We had monitoring equipment with us all the time when we were working anywhere in the vicinity of radioactivity.
When you went into your workstation, you picked up a film badge and 2 pencils. The pencils then were read every night when you left. If they showed some evidence of radiation, then your film badge was developed to check to see what it was.
One of the most hazardous parts of production would involve unloading the cooked, irradiated fuel.
During the discharge, no one was allowed into the back of the reactor. The doors were electronically locked. How radioactive was the fuel coming out? If you were out there when the fuel slugs were being dropped out, your life could be measured in seconds rather than in minutes.
The fuel rods were ejected into 20-foot pools of water to cool and allow time for short-lived radioactive decay. The water barrier also protected the workers from radiation. The rod, still underwater, then traveled about 8 miles by lead-lined rail cars to mammoth canyon-like buildings nicknamed the Queen Marys.
The material came in at the far end of the building, way down there. This building is 800 feet long, and there are 40 cells on the other side of this wall.
In a series of complex steps, the plutonium was chemically separated from the uranium.
The first thing we'd have to do is take the aluminum jackets off of the fuels that came in. That was done with sodium hydroxide. Then they dissolved the uranium with nitric acid. We would move it from cell to cell, and each section it went to, it became cleaner and cleaner plutonium. You're always working remotely in all these buildings. You never get down and directly in contact with that material until you finally take it out of the final step. For every ton of uranium that we put into a reactor, we made 1/2 pound of plutonium. And it takes about 5 pounds of plutonium to make a weapon. So you can see the amount of waste that we had.
During the war, more than 60 storage tanks had been built to hold the radioactive liquid waste. Toxic gases were released into the air.
Back in the early days, we didn't have any gaseous suppression system. We would see brown fumes coming out of the stacks. Later, we improved the system and we were able to absorb a lot of that.
In February 1945, the first small shipment of plutonium, about 1.5 pounds of paste-like material, was ready for Los Alamos.
Colonel Mathias decided to deliver it personally himself. He had it in a little case, a little box, and the box was probably no bigger than, say, 2 shoe boxes put together, and it was tied with a rope. He was driven by Army ambulance, and then he got to Portland and he got on a train for Los Angeles, and he had this box with him. And this is a regular passenger train, and at Los Angeles, he was going to turn it over to an Army officer from Los Alamos. And the other fellow didn't know what it was, because nobody was supposed to know everything. And so for security, they kept the information very tight. And he asked the other man if he had a sleeping compartment on the train from Los Angeles to Los Alamos. And the man said, "No, I'm going to rough it. I'm just going to sit sleeping up. I'll put the box under my feet." And remember, this is plutonium. And Mathias said to him, "I think you better get a sleeping compartment with a locking door." And the man said, "Why?" And Mathias still wasn't going to tell him the real reason. So what he said was, because what you're carrying costs $350 million, which is, of course, the price tag of the entire Hanford project.
By the end of February 1945, 3 reactors were producing plutonium at full power.
June 8th, 1945, emphasized to staff members that no effort was too unimportant to speed up production, and there are no obstructions to the rapid processing of the product. Franklin Mathias.
Los Alamos was crying for more and more plutonium. We were working as hard as we could. I think there were 3 shifts a day. If something went wrong during the chemical processing at the last step, we had to know, we had to take samples of it. There were problems that arose, but we solved them.
This is the darkness of a desert morning, and here in New Mexico, a group of men wait tensely, expectantly.
On July 16, 1945, the first nuclear device in the world, fueled with plutonium made in Hanford, exploded in a test called Trinity.
It was the first atomic test down at Alamogordo, New Mexico. The article doesn't say it was an atomic bomb. They say it was just ammunition of some sort, but don't describe it. Secrecy was still very prevalent then.
There was a rumor at Hanford that that something happened, that even at the upper echelons at Hanford, I don't think anybody really knew that Trinity had come off.
Harry Truman was vice president under Franklin Roosevelt, and most of the time that the project was being built, the vice president didn't even know about it. It was that secret. Now, President Roosevelt died in April 1945.
Vice President Harry S. Truman takes the oath of office as 32nd.
And at that time, Mr. Truman became president, and that's when he was told.
On August 6, 1945, a uranium-fueled bomb was dropped on Hiroshima, Japan.
The world will note that the first atomic bomb was dropped on Hiroshima. We won the race of discovery against the Germans.
President Truman made an announcement to the nation, and he revealed that there is a place called Hanford, and they're also working on atomic weapons, and the workers had no idea. They walked out into the streets and were just clapping and shouting, celebrating, but saying, "I didn't know, did you know?" And nobody knew.
August 6th, 1945. By afternoon today, the area around Richland was besieged with reporters, newsreel people, and radio people to get first-hand accounts of the story of Hanford for their newspapers and radio stations. There is a consciousness in the minds of people directly working at the Hanford Project that they have contributed to the mechanism that will certainly end the war very soon. Franklin Matthias.
3 days later, on August 9th, a second bomb armed with plutonium made in Hanford exploded over Nagasaki.
A great towering mushroom effect could be seen going higher and higher and reaching into the stratosphere.
It's estimated that the two bombings killed or injured about 200,000 Japanese citizens. And in the months to come, thousands more would die of burns and radiation sickness.
When the bomb was dropped, everybody thinks that probably saved at least 1 million Americans who would have had to invade the Japanese homeland. Happily, that never had to happen, and I was glad of that. I was sorry that so many innocent Japanese lives were taken. I hope it never happens again. That was the downside of it.
Kind of have mixed emotions, really. I'm proud to have been here and helped gotten the war effort to move along. But at this particular time, I might actually go so far as to question whether it was necessary to have dropped the bomb, but I think we saved thousands of lives by having done that.
When the atomic bombs were dropped that ended World War II, many people thought Hanford would just be closed, and they would just put a fence around it and tear down the buildings.
It was a question of whether we were going to continue making the material even in the first place. Is it necessary? But then the information was that Russia had essentially stolen our technology and was in the process of also beginning to make an atom bomb.
By that time, it was 1947, and the world was a different place, and the Soviet Union was making a play for dominance. And so the Cold War began, and Hanford didn't close, it got bigger.
By now, DuPont had bowed out, and General Electric had taken over as prime contractor. And under the direction of the new Civilian Atomic Energy Commission, the largest federal peacetime construction project in American history began. New barracks and trailers in North Richland became home to thousands of incoming workers.
We've got to get going and beat Russia. There was no question about it. And the reactors were getting a little old and a little decrepit, and having a little problem with them. And that's when they began replacing the reactors.
I ended up here in 1947. I was just 16 years old out of high school, graduated high school when I was 16. Well, I did move out into the outer area, into the 100H reactor that was under construction. And I worked as a common laborer out there at 100H here, and I worked a swing shift.
General Electric operates here a fleet of about 90 buses that carry almost 2 million passengers a year.
We were still making plutonium. And then when we found that Russia was making plutonium, it became even more critical.
The arms race had begun, and in 1949, the Soviet Union exploded its first nuclear weapon.
It was an exact copy of the Nagasaki weapon down to the wiring mistakes. It was exact.
A year later, the Korean War began, and President Truman decided to pursue the development of a more powerful hydrogen bomb.
A lot of people don't realize that we made the material for the first hydrogen bomb at Hanford.
It was tested in the Marshall Islands in 1952. The Soviet Union followed with their own test a year later.
The hydrogen bomb, the bomb that Khrushchev announces will once again undergo tests by the Russians.
As the Cold War escalated, security at Hanford intensified.
They really pounded security into us.
And demand for plutonium soared as America stockpiled a nuclear arsenal.
This is atomic energy.
The stronger our home front defenses, the less the chance an atomic attack will come.
They were increasing the powers in the reactors so we could make more plutonium in the reactors. And they began building what they called the super reactors, which were about 50% larger than the old original reactors. We were building additional waste tanks to hold the waste from the separation process. And we were running out of waste tank storage space like crazy there for a while, but that didn't matter. Get that stuff out, get it on the train down to Los Alamos.
Other contaminated materials were buried in trenches by each reactor.
So we knew we was doing it, but we also knew it was a very necessary thing. If you were going to have this protection of a bomb, you've got to do it.
Hello, everybody, from Richland, Washington. Our NBFC camera and microphone are set up in the midst of the community, which has grown more rapidly than any other in Washington State.
By the early 1950s, Time magazine had called Richland a thriving atomic utopia.
Boomtown is hometown now. And there is a tremendous amount of research going on here.
At Hanford, biologists study the effects of radioactivity on fish. These experiments could be of tremendous importance, increasing their understanding of the processes of human life.
A whole new technology was being born, and a lot of it was being developed right here at Hanford.
But Hanford's mission had also made the area a prime target.
There was a fear of bombing, that we might be attacked by bombers.
We had anti-aircraft batteries circling the plant up on Rattlesnake Mountain. We had an army base in North Richland for the people to man these sites.
It was a little scary one night when we were on our way home at shift change at 4 o'clock. The aircrafts at the bottom of 2 East Hill were all pointing skyward, and we wondered, are they on an alert? We didn't know. They didn't tell us.
By 1959, Hanford was operating 8 plutonium-producing reactors. That year, Hanford began building one more.
N reactor, which is our newest reactor, is going to make a dual-purpose reactor of it. They wanted to be able to, instead of making just strictly plutonium, They wanted to be able to produce electricity also.
It was the first time that we were able to really capture the heat from a reactor to generate electricity.
We begin work on the largest nuclear power reactor for peaceful purposes in the world, and I take the greatest satisfaction in the United States being second to none.
In late September 1963, President John F. Kennedy came to Hanford to dedicate the new reactor.
Oh, that was a very significant day. It was the first day that they were allowing people to come out onto the site for that dedication.
All this means that we put science to work in improving our environment and making this country a better place in which to live.
Peak production at Hanford was between 1956 and 62. Of course, by 1963, Kennedy was assassinated, and President Johnson began to go in a very different direction and closed a lot of the Hanford plants.
You could see the handwriting on the wall. It's going to happen. You just can't keep doing this and putting this plutonium in a hole in the ground.
In 1968, B reactor was shut down, and by 1971, there were 8 reactors no longer operating.
We had produced enough plutonium, essentially, to blow up the world. We just didn't need any more.
A nuclear war cannot be won and must never be fought.
As the Cold War was coming to an end in the late 1980s, N reactor was shut down too. But a new environmental awareness had been gaining traction in the United States years before.
The wastes are one of the most serious environmental problems faced in this country.
By the early 1970s, leaking underground storage tanks were drawing intense criticism. And scientists were debating new safety standards for radiation protection and exposure.
Even during World War II, DuPont was extremely concerned about the emissions of radioactive material, emission of hazardous materials.
And they began a fairly small monitoring program. This environmental monitoring program was world-class, with one exception. It classified and held secret its data. The entire country and community of scientists might have been able to work on these problems, but we're not told, and certainly the residents and the people here were not told.
In 1986, the Department of Energy began releasing thousands of pages of historical documents detailing the operations at Hanford. Largely because of the massive amount of data available, Hanford, once shrouded in secrecy, would become the most scrutinized nuclear waste site in the world.
Hanford, first of all, has so much waste. It has 2/3 of all the nuclear waste in the entire nation in one place.
Our mission's cleanup. That's all we do. Probably our biggest technical challenge on the Hanford side is the treatment of the underground stored waste in the underground tanks. There's 177 underground tanks. The waste treatment plant is being built to treat that waste, about 56 million gallons, and it's a very challenging job to figure out how to vitrify or glassify that waste in a safe manner.
Today, the cleanup at Hanford is costing U.S. taxpayers about $2 billion a year. The process has been plagued with technical problems and delays and will most likely continue for generations to come. In contrast, the Hanford Reach area, once part of Hanford's security buffer, has been untouched since 1943. This land is considered ecologically pristine and was named a national monument in 2000.
The Hanford Reach is the only free-flowing part of the Columbia River from Canada to the mouth in the Pacific Ocean. It's the only place that looks like it did 100 years ago or 200 years ago. So that's one of our greatest responsibilities, in making sure we preserve and conserve those resources.
Downriver, the shell of Hanford High School is all that's left of the town site, evacuated decades before.
There were several hundred people here living at Hanford. This high school that used to be so vibrant, it was the center of the community, and it represents to me many of the dreams that they had. It belongs to the American people, and we would like to save it.
The few reminders of life in White Bluffs have also yielded to time. Like Hanford High, the old town bank is crumbling, and sidewalks point to sacrifices made long ago.
In 1968, we were allowed to go out to our former home sites, and I seen my father cry. But my dad loved that place. He would have probably died there. But it just didn't work out that way.
The town of Richland ceased being government-owned in 1957. Today, the area is a fast-growing science and technology hub that celebrates its past and future.
And people are proud of it, and they're saying Hanford led the world in the nuclear business, and we're also leading the world in cleanup.
The nuclear reactors built over the years stand like tombstones in an atomic frontier. 8 are now sealed or cocooned in concrete, or are in various stages of decontamination and containment. B reactor was named a National Historic Landmark in 2008 and is open for public tours. Many hope it will become part of a national park commemorating the Manhattan Project, a project that changed the world and continues to challenge it today.
Hanford is unique. Now, we've faced desperate times before in the American Revolution and other crises in our history, but to meet it on such a massive scale, one place, one time, one short burst, and to have the whole thing succeed, I don't know of any other time in American history that has occurred.
I think everybody from the University of Chicago to Oak Ridge to Hanford all felt like pioneers. Everybody that was involved, all the hundreds of people that were involved felt that they were doing something that's never been done before, and they knew what was at stake.
Hanford played such an important role in terminating World War II. It's important to remember what happened.
There's more about Hanford on Oregon Experience online. To learn more or to order a DVD of the show, visit opb.org. Funding for Oregon Experience is provided by the Robert D. and Marcia H. Randall Fund for Lifelong Learning, the James F. and Marion L. Miller Foundation, the Oregon Cultural Trust. Additional support provided by Kei Kitagawa and Andy Johnson Laird, the Clark Foundation, the Roundhouse Foundation, Fran and John von Schlegel, and viewers like you. Thank you.